Okay guys, just welcoming any grade 8, 9 or 10 learner that would like to get assistance maybe with any particular topic, any particular thing that you'd like me to cover. But this is strictly grade 10 if you're in grade 10 or 8 or 9, not any other grade. I don't want any grade 11, I don't want any grade 12. I'm just specifically wanting to assist any grade 10, 8 or 9 learner. So if there's something that you would like explanation, something that you'd like me to cover for grade 10, 8 or 9, now is the time. You can let me know in the comment section what it is that you'd like assistance with. If not, then I guess I am not going to do anything. I'm just going to end the live, and that will be that. Press C, factorization. Okay, so press C, what grade are you in? In grade 10. Okay, I'll do factorization, definitely, no problem. I'll be happy to do factorization. Proceed. Yeah. Grade 9. Are you guys have you already started factorization, Prissy? Or is that like you anticipating that topic in upcoming terms? Do you know that grade 9s have already started with factorization? Are you doing... Okay, so let's do this then. Prissy has asked for grade 9 factorization, okay, and I'm all too happy to do factorization. But let's first start off at the foundations of what is obviously supposed to be in check when doing factorization. Otherwise, I'm happy to do that with you. So do you have time, Prissy? 45 minutes. That's all I actually have to offer. I don't have more than that. SVM is saying grade 8 interest rates. Okay, so let's just check out factorization first, and then we'll see if we can't get... I see, so SVM, you're specifically talking about financial mathematics. Okay. So first and foremost, when we talk about factorization, we can't help but talk about this concept that you have been doing for the past few years in grade, what is it, grade... It seems like this person who asked for factorization is not even here. So maybe not. Maybe let's not do then factorization. SVM, I see, okay. Oh, they just rejoined because I was like, why do a topic when this person is not around? Okay. All right. So when we talk about factorization, we can't help but talk about the fact that we've done certain types of factorization already. There's types of factorization that we have looked at in the past, where we were asked to find the highest common factor. Now I'm just gonna look for that in terms of our numbers. Now, whenever you were asked to find the highest common factor between two numbers, let's say for instance, let's say we were asked to find the highest common factor between 25 and 15. What you have now learned to do in grade 8 is to actually use the famous, what we call the ladder method. All right, you would actually write down 25 and you would find the product of prime factors for 25. So you would ask yourself, what is the lowest prime number that goes into 25? Okay, and the lowest prime number that goes into 25 obviously here would then be what? It would be 5. How many times does 5 go into 25? 5 times. Then you'd ask again, what is the lowest prime number that goes into this 5? It would be 5. How many times does it go? Once. Then your 25, your product of prime factors for 25 would be 5 times 5, which is 5 squared. You do the same thing with 15. You'd find the lowest prime number that goes into 15. That's 3. How many times does it go? 5 times. Lowest prime number that goes into 5 would be 5. How many times does it go? 1. Then you write down your number 15. 3 times 5, and obviously that's just 3 times 5. Then when you are finding your highest common factor, we would here then choose the common base that has the lowest exponent. Common base that has the lowest exponent. And here lies the trick in factorization. The fact that between two numbers, for instance, we always are going to be choosing the common base that has the lowest exponent. So if we look at 25, the prime factors of 25 are 5 squared. Then the prime factors, or at least the product of prime factors for 25 is 5 squared. The prime factors of 15 are 3 times 5. From there, we can now write down the highest common factor. We look at the prime factors, we can see what is common, because we are choosing the common base. Now, what is common here? 3, for instance, is only there for the number 15. But 25 has no base that is 3. So that means 3 is not a common base. So that means 3 is not going to be included as part of our highest common factor. But if we look at 5 squared and 5, obviously this 5 and this 5 are common bases. So we are going to choose the common base that has the lowest exponent. So between 5 squared and 5, which base has the lowest exponent? It's obviously 5 to the power 1. So then that means our highest common factor is going to be the number 5. Because like I said, from our factors that are prime, we choose the common base that has the lowest exponent. That's what we do when we choose the highest common factor for our numbers. Okay. Then I want to look at something else as well. We look at how do we identify the highest common factor between variables. Okay, so let's say we have x to the power 3 and x to the power 2. And the question is, what is the highest common factor between x cubed and x squared? So once again, the concept is very clear that we must choose the what? The common base with the lowest exponent. So between x cubed and x squared, the base x is common. But then for our highest common factor, if I'm asking what is the highest common factor between x cubed and x squared, I am going to see, okay, these bases are common. X and x are common variables. But I'm going to then choose the base with the lowest exponent. So that means my highest common factor would be x squared. Very important. So in a numerical sense, meaning when you are dealing with numbers, we must know how to identify the what? The highest common factor between numbers. And in the same vein, we need to know how to identify the highest common factor between our letters, all right, or our variables. Variables are simply the letters of the alphabet for a particular expression. So for instance, x cubed, this is an expression. It has a letter of the alphabet, and then you can see there's an exponent there. This is also a variable, all right, and it represents something that we do not know as of yet. It's a variable. What it does, a variable stands in the place of a number we don't know yet. A number we don't know. That's what a variable is. So in these two variables that are the same, we identify the base that has the lowest exponent whenever we are talking about the highest common factor. Right. Maybe you're gonna be wondering, why is this guy even starting with this when he obviously needs to teach me about factorization? This concept is very important for highest common factor, choosing the common base that has the lowest exponent. So now let's go and look at a few questions where we are asked to factorize. So at the foundation of factorization is the fact that when we have, let's say for instance, so this is a grade 9 topic, guys. For grade 9s, when we are doing grade 9, we usually start at this place, okay? So here they will say factorize, okay? In other words, here in this particular question, we need to do the following. We need to take out the highest common factor first and foremost. All right, we need to take out the highest common factor. So what we have here is we have two terms, okay? All right, so here we have 12, and this 12, we call this 12 a coefficient, okay? Coefficient. Coefficient is the number that stands before a variable. Okay, so now you can see the other terms. X is what we call a variable because it's a letter of the alphabet. It stands in the place of something we don't know. And then this 2 is what we refer to as a exponent. This plus sign is what we call, obviously it's a plus sign, but what it does is that it separates terms. There are two things that separate a term, all right? Your plus sign separates a term, and your minus sign separates a term. Those are the only things that separate terms. Minus and plus will always separate terms. Then you have 8, which is also a coefficient, x, which is also a variable, and 4, which is also an exponent. So we have 12x squared, just going to rewrite these, plus 8x to the power 4. All right, so we are now going to ask ourselves, what is the highest common factor between the two terms? And we first look at the number. Okay, there's this thing that I usually refer to as S and L. So whenever we are factorizing, we always take into consideration how many terms do we have. So here we have, like I said, 2 terms. Why? Because remember, what did I say? What separates terms? A plus and a minus sign. This 12 and this x squared are joined together. And maybe you're asking yourself the question, what is joining the 12 and the x squared so that they are combined? The relationship between 12 and x squared is one of multiplication. So for instance, 12 times x squared will give you 12x squared. So multiplication does not separate terms, but it combines terms. All right, multiplication combines terms. That's why we refer to this here 12x squared as one term. Plus then separates the term 8x to the power 4. 8 is a different, 8x to the power 4 is a different term. And remember, this 8 and this x are combined by what? By multiplication. Now you don't see multiply between 12 and the x squared, but I want you to know that 12 and x squared are combined by a multiplication sign. So that's why we can say how many terms are in the expression. There are 1, there's a plus sign, 2. So there are 2 terms in the expression. So that's why it's important to first start and ask yourself, how many terms are in the expression? There are 2. Then the next question, what is the highest common factor? And when you ask that question, you need to look at the S, meaning what is the highest common factor sign? 2, what is the highest common factor number? 3, what is the highest common factor letter? Remember, in algebra, we say that that letter of the alphabet X is called the variable. And we said a variable, it stands in the place of something that we do not know. So for all my grade 9 learners, that's very important to understand at the foundation of algebra, is the fact that whenever we are factorizing, we consider the highest common factor sign, we need to take that out. The highest common factor number, we have to take that out if it's there. The highest common factor letter, we have to also take that out. Now, what informs our highest common factor sign? So whatever the first term's sign is, that is the highest common factor. Whatever the first term's sign is, that is the highest common factor. All right, so we look at this, we're like, okay, 12x squared plus 8x to the power 4. Our first term, what sign does the first term have? The sign for the first term, if we look at the 12, it is a positive 12. So that means for our highest common factor sign, we are going to take out a positive sign. But that positive sign, guys, whether you write it or you don't, still means that that positive sign has been taken out. We move on to the next step. We ask ourselves, what is the highest common factor number? Now, you will remember that whenever we in grade 9 used to check what is the highest common factor number between two numbers, we would apply prime factorization. Then we would identify the base with the lowest exponent. The product of those would give us our highest common factor. So you could say in the side, if you don't know off by heart, I mean, it is something that is very common that in most times people can easily identify the highest common factor off by heart. But let's say you don't. So we are going to have to take the 12 and this 8, and we are going to ask ourselves, what is the lowest prime number that goes into 12? It is 2. How many times does it go? 6 times. The lowest prime number that goes into 6, 2. How many times does it go? 3 times. How is the lowest prime number that goes into 3? Is 3. It goes into 3 how many times? Once. So that means 12 is equal to 2 times 2 times 3, which is actually 2 squared times 3. We go to 8. Lowest prime number that goes into 8 is 2. How many times does it go into 8? 4 times. Lowest prime number that goes into 2 into 4 is 2. How many times does it go into 4? 2 times. And then what's the lowest prime number that goes into 2? 2 goes into 2. How many times? Once. So that is 2 times 2 times 2, which is actually 2 to the power 3. Okay, so that means 8 is equal to 2 to the power 3. Now, when we identify the highest common factor, what did I say to you guys? I said the highest common factor will simply be the common base that has the lowest exponent. So between these two, what is common? It's obviously base 2. Is base 3 common? No, because base 3 does not feature as one of the prime factors of 8. So then which base has the lowest exponent? It's this one, the 2 squared. So we're going to write 2 squared, and we know that 2 squared is actually equal to what? To 4. So now we can clearly write down that our highest common factor number is the number 4. Okay, then lastly, our highest common factor ladder between x squared and x to the power 4. What is the highest common factor variable? So remember, once again, we go back to our concept that whenever we are choosing the highest common factor, we choose the common base that has the lowest exponent. So x squared and x to the power 4 are common bases. Which base has the lowest exponent? Is it x squared or x to the power 4? Because that will inform what my highest common factor variable or letter will be. So is it x squared or x to the power 4? What is the highest common factor variable between x squared and x to the power 4? If I understand that whenever I choose the highest common factor, I choose the common base that has the lowest exponent. Okay, spot on. So my highest common factor variable will be x squared. So that means my highest common factor variable letter is x squared. So this here, guys, is my highest common factor, and I simply identified that highest common factor looking at, look, the two terms, their sign. If the first term of my expression has a positive sign, I will take out a positive sign. If my first term of the expression had a negative sign, I would have taken out a highest common factor negative sign. But in this case, because my first term is positive, the highest common factor sign is positive. Moving on to the number. Between 12 and 8, what is my highest common factor number? The highest number that goes into 12 and 8, guys. The highest common factor number that goes into 12 and 8 is 4. Alright? Alright? And then lastly, between x squared and x to the power 4, what is the highest common factor variable, meaning the base that has the lowest exponent? It is x squared. Okay, so that is why when I take out my highest common factor, I'm going to write down 4x squared. That is my highest common factor. Then I open some brackets because I want to check, since I've taken out 4x squared, what is now left over on the left hand side? Since I've taken out 4x squared, what am I left with on the left hand side? Okay, so in order to know what is left over now on the left, since I've taken out 4x squared, I'm going to ask myself, 4 times what gives me 12? Or in reverse, if we look at the inverse, you could say 12 divided by 4 is equal to what? Yes, this is grade 9. I repeat, you can either say 4 times what gives you 12, or in reverse, you could say 12 divided by 4 is equal to, and then you get your answer. Do you see that? So 4 times what gives you 12? It is 3. If you don't want to think of it that way, you could say, what's 12 divided by 4? That is 3. Guys, please, okay, if you do not take out a highest common factor, then you have not factorized correctly. If you simply look at 12 and 8 and you're like, 2 is the highest common factor. Guys, 2 is not the highest common factor. 2 is not the highest number that goes into 12 and 4. 2 is not the highest number that fits into 12 and 8. Okay, it is 4 that is the highest number that fits into 12 and 8. Hence we took out 4. Then between x squared and x to the power 4, we take out the common base that has the lowest exponent. Right? So that's very important. Then what's 12 divided by 4, guys? Now we want to find out what's left over. Okay, we've taken out 4x squared, but now what's left over? What do we have left since we've taken out 4x squared on the left hand side? What's left over? So we can either say 4 times what gives you 12. You can think of it that way. Or you can say, what's 12 divided by 4? 12 divided by 4 is 3. So that means the 3 is what's left over. If we look at the variable, we took out x squared. We want to have x squared. Do we have to put in any other x's on the left in order to actually make up for what we had left over? No, that is enough. The 3 is enough. We don't have to add any additional variable so that we have 12x squared. You can even now check, what's 4 times 3? It's 12. And then the x squared, it will just be combined next to the 12. So this is done. For our left-hand side, we are done with the factorization. Now it's time to go to the right-hand side. Now, for that purpose, we took out something that was positive. We want something that is positive. What is a positive times what gives us a positive? Because that will inform the sign that is left over for our right side. Okay? That is positive that we are left over with. Kiyotaka, chief, is for the highest common factor. Yes, Kiyotaka, it is the highest common factor. Between 12 and 8, our highest common factor is 4. Because remember, when we are thinking about the highest common factor, we are thinking about that number that fits into 12 and 8, the highest number, because that's why we call it the highest common factor. It is the highest number that fits into 12 and 8. Okay, so 4 times what gives you 8? That's how you can think about it. Or alternatively, you can say, what's 8 divided by 4? It is 2. Okay, then in the same vein, x squared, you have 2 of your x's. You would like to have 4 of the x's. How many x's would you like to add to the 2 x's in order to get 4? You would like to add 2 x's in order to get the 4 x's. And maybe you're asking yourself the question, why is this guy saying how many x's would you like to add to these 2? Remember, guys, that when you did laws of exponents, what did you guys learn is the rule when we are multiplying same bases. I'm sure you can remember that the rule says that when we are multiplying same bases for exponents, we keep the base. We then add the exponents. That's what we know when we are multiplying same bases for exponents. So all my grade 9s at this stage should know this from the grade 8 syllabus. So like I am now saying here, you see my logical thought process. I am asking, since I took out 2 of the x's, I would like to have 4 x's. How many x's do I need to add to these 2 in order to get 4? So I've taken out 2 of the x's. How many x's do I need to add? This comes from the fact that I know that x and x have the same base. So I'm asking myself, how many of these x's do I then need to add to these 2 in order to get 4? 2 of these x's. So that's why we have x squared. And guys, my factorization is complete. That is how we factorize. So any grade 9 that is here, you might have that question: how do we factorize an expression? This is how we do it. All right, and that's simply how we do it. And even a grade 10 learner should know those steps of factorization. Okay, let's look at another one. Let's say we had 15a to the power 4b to the power 6 minus 3ab squared. Right? Once again, let us factorize this. All right? So once again, when we are factorizing this, what do we do step by step? Remember, we first ask ourselves, how many terms do we have in the expression? How many terms in the expression? And simply put, guys, how many terms do we have in the expression? Remember, what separates terms is a minus sign. So that means we have 1 and then 2. There are 2 terms in the expression. Okay. First question answered. 2. What is the highest common factor? We need to take out the sign, the number, the letter. So let's first identify the highest common factor: sign, number, and letter. So first question, what is the highest common factor sign? Remember, what dictates the highest common factor sign is the sign of the first term. So the highest common factor sign, the first term has a positive sign. So our highest common factor sign is plus. We take out a positive. We move on to the next thing. What is the highest common factor number? So between 15 and 3, because we are done with the signs now, what we are looking at now is the numbers. 15 and 3, the coefficients of the variables. What is the highest number that fits into 15 and 3, between 15 and 3? Okay, so I'm sure you guys can see very clearly that highest number between 15 and 3 that fits into both, it is the number 3. Then we move on to the letter. Now, we have 2 letters combined. We have A and we have B. On the left we have that, and on the right we have A and B. So, remember, what did we say? We choose the common base that has the lowest exponent. So this is A to the power 4. This is A. The exponent for A for the first term is to the power 4. The exponent for A for the second term is to the power 1. We don't see that 1, but it's there. So we choose the base that has the lowest exponent. What is that base? It is A. Then we look at B to the power 6 and B to the power 2. We choose the base that has the lowest exponent. What is that exponent? The base that has the exponent. Yes, it is B squared. I am done taking out my highest common factor using my sign, number, letter, S and L, guys. Simply put, now I'm in the position to go and write 3ab squared as my highest common factor. Now, all I need to do now is figure out what is left over. On the left, what is left over? On the right, what is left over? So this is 3. 3 times what gives you 15? Or we can say, what is 15 divided by 3? We can use the inverse operation. Okay. Tebucho, I said that when we are taking out the highest common factor, we take out the highest common factor according to the sign, number, letter. Y is positive, my highest common factor sign. I said what dictates the highest common factor sign is the sign of the first term. The sign of the first term will dictate the highest common factor sign. Are you with me? So my positive sign can be written explicitly. If you wanted to, you could write positive there. But even if you don't write that positive sign is an invisible agent that is there and ever present. It is an invisible agent that is there. By the mere fact that we don't write that positive means that that positive is there. Okay? So I hope that makes sense. So that's why we say highest common factor sign. That's why I say, guys, when you are factorizing using highest common factor, think of S and L. Highest common factor sign, highest common factor number, highest common factor letter, and you won't go wrong. If you do that, highest common factor will be identified. But it's very important that you must know how to identify the highest common factor number. As I had explained, this speaks back to the concept of highest common factor between two numbers. You must be able to identify the highest common factor number using your previous grade knowledge of identifying highest common factor number. Then secondly, let the variable. The highest common factor variable is always the common base that has the lowest exponent. So between a to the power 4 and a to the power 1, the base that has the lowest exponent. By exponent we mean these numbers at the top. The base is a, your exponent is 4. Your base is a, your exponent is 1. So which one has the lowest exponent? It's a. Then for b to the power 6, your base is b, your exponent is 6. Your base is b, your exponent is 2. These bases are common. Which one has the lowest exponent? It's b squared. Then you've identified your highest common factor. What is left over? Your bracket is there now to record what is left over. So what did I say? We look at the sign, it's positive times another what, that gives you a positive. We know, guys, that from previous grades as well, a positive times a positive gives you a positive, and negative times a negative gives you a positive. Same signs that are even, that are multiplied, give you a positive. A positive times a negative gives you a negative, whereas a negative times a positive also gives you a negative. Okay, so very important how to know these things about your sign. So like I said, you have a positive times what gives you a positive. Obviously that's a positive number, so that positive you don't have to write it, because by the mere, it's an invisible agent that is ever present. 3 times what gives you 15, or 15 divided by 3 is what? Obviously it's very evident, it's a positive 5 that's left over. A, one of the A's was taken out. We need 4 of the A's. How many A's do we need to add? You see, one of the A's was taken out. We need 4 at the end. How many A's do we need to add? Yes, we need to add how many A's? 3 of them. 3 of the A's. Very important, guys, because that's what's left over from the 15a to the power 4, b to the power 6, after taking out 3ab squared, which is the highest common factor. Then b squared, 2 of the b's were taken out. We need 6 at the end. How many b's do we need to add? 2 b's were taken out. We need 6 at the end. How many b's do we need to add? B to the power 4, guys. Okay, and remember, where is that coming from? Bases are the same, brackets mean multiply. A times to the power 3, this a times this a to the power 3, we keep the base, we add the exponents. So this 1 plus 3 gives you back the 4. Okay, yes, definitely. This b squared. All right, so yes, you could say 4 minus 1 gives you 3. 6 minus 2 gives you 4. You could simply just do that, definitely. Okay, remember, addition The inverse of addition is subtraction, all right? But as long as we are applying our knowledge of what we know, because we know that when the bases are the same and we are multiplying, we keep the base, we add the exponents. So yes, in the same vein, in reverse, you can say 4 minus 1 gives you 3. 6 minus 2, the 4 is there. Now, positive times what gives you a negative? It's a negative sign that will give me that outcome. Then 3 times what gives you 3? It is 1. Very important. Then the a, there's one a taken out. You need 1 as well. Do you need to actually add any more a's? No, because 1 minus 1 is 0. A to the power 0 is 1. Okay, remember? 2 minus 2 gives you b to the power 0. So does that mean you need to add any more b's? Not even. Yes. So yes, therefore you could say 3 negative 3 divided by 3. Very important, because there's a negative sign. Negative 3 divided by 3, you get that negative 1. Okay, right? Yeah, you can say, guys, here this is just a matter of how you think about it. Whether you want to think of it in the inverse way, division 3 divided by 3, and it's easier for you, go ahead, have fun. If you want to think of it in the way of 3 times what gives you, have fun. However the best way is for you, please stick to that. Then that's fine. All right, I'm pretty happy as long as your thinking process is not incorrect. Okay, that is very beautiful. So nice. There it is. Done, dusted. Okay. Sammy do NBT questions. I must say I haven't as of yet even stepped into that world of NBT questions. So I think I know that there are people that sort of like do that sort of like mathematics, and they help people with NBTs, but personally not there yet. Still foundational, guys, still very foundational. I'm still within the high school context, very much so. So, and do check out someone that could be of assistance there. Yes, I do tutor. You can, I mean, personally, privately, if you want, just send me a message, and yeah, we can talk on the side. Just send me a message inbox there. Okay, right, that was highest common factor. How nice. Let's look at another one. Maybe slightly different from what you have been doing. Okay, and guys, when we have factorized, you can see that inside this bracket there's nothing more that you can take out, right? You will know that you've factorized 100% when it comes to highest common factor if you can look at your inside of your bracket and ask yourself, is there anything more that I can take out? And you can see there's nothing more that you can take out. So that means you really did identify the highest factor between 15 and 3, and that's what you took out. So that's why there isn't any more highest common factor factorization that you can do. But if you find yourself in a situation where you've taken out a highest common factor, and then inside the bracket you can say, hi bo, there's something more I can take out, then it means you did not highest common factor factorize. Okay, so let's be very careful about that. Yes, Fef1, I am. Okay, so x into a plus b minus y into a plus b. Okay, let's note a few things just before we jump into the question, because remember, there's a few questions we need to ask ourselves before we jump into answering a particular question. So first and foremost, here's something to note. If I was to say a plus b, and then I ask you, how many terms do we have in the expression? What would you say? A plus b, how many terms do you see in this expression? Okay, how many terms do we have here? Okay, fair font, very true. We have 2 terms in the expression. Remember, guys, I said to you that a plus sign, what does it do? It separates terms. So that's why you can comfortably say to me that there are 2 terms in this expression. Okay. Now, let's say I changed things a little bit and I said a plus b, and I put brackets around, and I asked, how many terms does this expression here represent? How many terms in this entire thing? How many terms do you have here? Okay, Fanny says 1. Prissy says 1. Fairphone says 1. Okay, you guys are amazing. Okay, Ngutuku says 2. Now let's be very careful. Okay, so for this one, yes, there are 2 terms. We agree. For this one, we say 1 term. If you did your grade 8 syllabus well, then you should look at this and be like, I said this is 1 term. Why? Now I want to ask in the comment section, since you guys are coming from grade 8, why are you saying there's 1 term in this expression? What makes it so that we say it's 1 term? What is the basis of us saying it's 1 term? Yes, very good. Brackets. Brackets make it 1. Brackets make it 1. Brackets make it 1. Yes, brackets make it 1. So, sir, are you saying, in other words, that I could have something like this, for instance, sir? I could have something like this, sir, and I come here and you say how many terms in this expression, and then you tell me it's 3, and then all of a sudden, if I put brackets around these 3 terms, all of a sudden, because of the brackets, you say how many terms? How many terms would this be if I put the brackets around? You see exactly. It's 1 term. So brackets have this function of just combining everything, you know? Yeah, all of a sudden, we say it's 1 term when there's brackets around. So you must take note when there's brackets around. When there's brackets around, there's a union. We unite. We become 1. It's almost as if it's like the country at the moment. I'm sure you guys have been seeing the Justice for Kwekwe, sort of like a hashtag. It's been going on now for a while. And you can see the unity that has basically, occurred. You know, people who would normally be separate and apart, all right, different corners of the country, or like in a particular city, you can see people now are joining together. There's these marches that are happening. People are becoming united and one under this one banner of Justice for Kwekwe. And basically, that you could say that Justice for Kwekwe is playing a bracket role. It is uniting people. They are becoming 1. So I'm just making that example just so that the brackets here can sort of like have weight. So there's 1 term whenever we have a bracket. Okay. Right. X into a plus b minus y into a plus b. So if we look at this expression, my question is, the first question I ask you, how many terms do we have in this expression? How many terms, people? Okay, Tebucho says 2. Tumza says 2. Okay, Precious as well, Precis as well. Okay, guys, you guys are spot on. Tumza, if you say 4, that's where the danger starts. Okay, there are no 4 terms here, Tumza. There are 2 terms. So let's look at the expression. There is x, right, followed by a bracket. Now, the bracket here means there's a relationship that exists between the x and the bracket. And that relationship, okay, is one of multiply. Okay, because brackets mean multiply. And that's what brackets mean. They mean multiply. So the x and the bracket are combined. So this is 1 term. All of this is 1. Then there's a separation of a sign here. Okay, and this minus sign, there's no bracket around it. So that means it really is separating. And then we have 2. So truly there are 2 terms here, guys. 2 terms, right? Now, since there are 2 terms, we've answered the first question, which we usually ask. Now it's time to identify the highest common factor. Okay. Yes, brackets bring everything together, like the hashtag banner of Justice for Kwekwe, bring everyone together. So HCF, highest common factor, sign, number, letter. Sign, number, letter. So let's look at this. The first term has a variable x, and then it has a bracket a plus b, but as far as the sign is concerned, it is a positive something, because here I can see the coefficient, it's not negative, it's actually positive. So that means our highest common factor sign is plus. Let's move on to the next thing. Our highest common factor number. Guys, we don't see it here, but there's actually a 1 here. Okay, it is the invisible number. Okay, so if we're talking about number, we'd say our highest common factor number is 1. Then highest common factor letter, x. If you look at this term and this term, x is not common, so x is not a highest common factor letter. We're not going to take it out, but we have a highest common factor letter in brackets. So a plus b, and we need to make sure we put brackets around. That is a highest common factor letter, if you will, our a plus b. It's what we call a common bracket. Even with our common brackets, we always check what is the exponent of each bracket, because each bracket, we regard that bracket as one term, but that bracket we need to check, we always identify the common bracket with the lowest exponent. Okay, I'm gonna do one last example D so that you can see what I mean. Look at this, x into a plus b. So this a plus b is common. It's there on the left, it's there on the right. So that means I'm going to take out a positive 1, a plus b. So look at this, a plus b is a common something bracket. Now you're gonna ask, where is the positive? Remember I said it's the invisible sign that is always there. Then you're gonna ask, where is the 1, sir? Why didn't you put the 1? Remember, 1 is also the invisible number that is always there. These two, hey guys, I don't know if you are seeing this. This is like, you know, sometimes when you look at maths, you're like, hey, God exists, that's for sure. The invisible positive. Man, guys. And God is invisibly positive, if you know what I mean. 1. He is the 1. 1 is also the invisible number. Okay. No. Remember, I said that we always take out, if the first term is a positive, then that means the highest common factor sign is positive. So the sign is not always positive. It always depends on the first term. If the first term is positive, we take out a positive. If the first term was negative, we would have taken out a negative. But in this case, the first term is positive. That's what dictates our highest common factor sign. The invisible plus and the invisible 1. Guys, for me, when I think about these things, that's why I know God exists, that's for sure. Okay, besides biblical evidence. Okay, a plus b, we take it out. What's left over? Remember, we took out x, a plus b. What's left over on the right? Hi guys, I'm sure you can see. If I take out the a plus b, take him out. Who's left over? At the left, on the left. Okay, who's left over? I'm sure you guys can see who's left over. Yes, Debucho, thank you. Precious M, very good. Ngutuka, thank you so much. Yes, the person that's left over is the X. Let's hide the side. Who's left over on the right? Because remember, the signs don't change inside because we took out a positive. So that's just something we can note as well, is that the signs don't change if we're taking out something that's positive. Yes, it is negative y. And that's it. Factorization done. Done. Factored. Finished. Finito. Completo. Comprendo. Okay. Okay. But let me do a few others just so that we can all be on the same page and maybe people as well can see. Let's say we had x squared into a plus b squared minus y into a plus b. Let's say this was the question. Okay? Let's say this was the question. So once again, yes, Tebucho M, that's very fine. Okay? You could say x minus y into a plus b. Why can you say that? It's because in grade 8 you learned that multiplication, whether you say a times b or b times a, doesn't matter. Multiplication is commutative. Okay, multiplication is commutative. The order don't matter. Okay, that speaks to the commutativity of the multiplication sign. The other sign that is commutative is when you have plus. That's also commutative. Minus and divide are not commutative, so plus and multiply are commutative. Remember the commutative property? Yes, very true. I love it. Tebucho, you're amazing. You got it down. Okay, so let's come back here. I want to do, yes, grade 9, guys. This is grade 9, but also relevant for grade 10. If you're a learner in grade 10, this would also be relevant for you. Yeah, so once again, we first ask ourselves, how many terms are in the expression? We start there, Moss. How many terms in the expression? Because it's always good to ask ourselves that first question. If that first question is answered, then we can go on to the next thing. Yes, beautiful. 2 terms. 2 terms in the expression. Why do we know there's 2 terms in the expression? It's because this here is term 1, and then that there is term 2. That's 1, our first term. That's 2, that's our second term. Beautiful. Beautiful. At this point, I just want to mention something. I do have a YouTube channel, guys, for those who are joining in for the first time, or maybe the second or the third time. Yesterday night, I actually did, for the grade 11 learners. You can go to my bio. There's a link in my bio. It's called Maths is a Game. Go to my bio. There's a link in my bio, not the WhatsApp channel link. Don't mind the WhatsApp channel link. I usually post, obviously, just share the information about YouTube videos that I've posted on my WhatsApp link. Go to my YouTube link. On my YouTube link, yesterday I uploaded for the grade 11s. I did quadratic functions. So I uploaded the video that I did of quadratic functions, just the introduction part for the grade 11s. Okay, please check it out. There's also other videos I uploaded of other content, like for the grade 11s. 2 days ago I did circle geometry, Euclidean geometry. I did the introduction part, the first 2 theorems in Euclidean geometry. So you can check those out. They are all in my YouTube channel. Very long videos. You can check them out. Please, they are there. Okay, at the moment I'm doing grade 9 factorization because a particular learner asked that I do grade 9 factorization. That's what we are on at the moment. I'm doing that. But remember, after I'm done with this live session, I will take the video, I will post it onto the YouTube channel so that people who want to rewatch it at their own pace can rewatch it over and over again. So thank you again for the support. All the people that have actually subscribed and that are watching the videos, thank you a lot. It means a lot. This allows me the opportunity to sort of do this live sessions for free without expecting anyone to really pay anything, and actually share the knowledge, the information, because it's key. Right. So x squared into a plus b, the whole thing squared, minus y into a plus b. We've agreed there are 2 terms, right? 2. Second question, what is the highest common factor sign? Thank you, Brenda. The highest common factor number, the highest common factor letter. So let's start with the highest common factor sign. Remember, our first term dictates the sign that we take out as the highest common factor. So the highest common factor, let's sign, this here is positive. So that means the sign that we take out, that's the highest common factor, is positive. The next thing, what is the highest common factor number? Obviously, the coefficient here is 1. The coefficient there is -1. We know much that the number there would be the number 1. But 1 are the invisible. The positive and the 1 are invisible agents. They are always there, but we don't necessarily have to write them down, especially when they are accompanied by a variable. We only have to write them down when they are alone. You see, like for instance, when we took out the highest common factor here and we wrote the term for the last term for the factor here, we had to actually write down that one because it's alone, very important. But if it's accompanied by a variable, it can be invisible. It just disappears, That does not mean it's not there. It is there, but it just means that it decides to not be visible for the eye to see. Okay, all right, so let's look at this. We take out the highest common factor sign, it is positive, the highest common factor number is 1. Then the highest common factor variable, x squared and y are not common. So we're not going to take out anything with x, we're not going to take out anything with y. Let's look at the bracket. Ooh, a plus b, a plus b. Now that is common. But look at the exponent for this a plus b, it's 2. Look at the exponent for this a plus b, the invisible 1. So what did we say when we take out the common base? We take out the common base or common bracket that has the what exponent. We take out the common bracket that has the what exponent, guys. We take out the common bracket that has the what exponent. Yes, Debucho, we take out the common bracket with the lowest exponent. So that means my highest common factor bracket will be a plus b. This one, not a plus b squared. So I am very deliberate about making sure that I don't put the squared there, but I make sure that I write a plus b. I know that one is there, the invisible one. Yes, Debucho, 100% spot on. So that is the common bracket. Remember, the sign I said is positive. Positive does not have to appear because there is something also there. The 1 can also be invisible. It's there somewhere, but we don't have to make it appear because it is accompanied by something. I said to you, 1 and positive only appear when they are alone. When they are alone, they must appear. But if they are accompanied by something, they don't have to appear. They can remain hidden, remain invisible. Just because they remain invisible and hidden does not mean they do not exist. Hey! I don't know if someone is hearing me, but I feel like I'm preaching a sermon simultaneously here. Just because they remain invisible and they are not seen, it does not mean they do not exist. Hey, mame, someone say hallelujah there. All right, anyways, so we take out the a plus b, and then what's left over on the right? If the a plus b has been taken out, the a plus b, one of the a plus b's has been taken out. Remember, on the left, how many a plus b's get left over? And that's very important. So yes, the x squared we must definitely write. Okay, but remember, we took out one a plus b. How many a plus b's do I need to add if I need 2 of them? I took out 1, I need 2. So that means 2 minus that 1 gives me how many a plus b's? 1 a plus b. So I need to write x squared into a plus b. On the left, I'm left with that, guys. Okay, very, very important. I hope you are listening to me here. I hope you are hearing me here. All right, okay. X squared is left over on the left, but together with what? A plus b. I took out the bucho, 1 a plus b. Remember, it was my highest common factor. Now, okay, let's just do this. I'm gonna write it in different colors. This is the a plus b that we took out. How come the exponent for x is 2 when the power is only on the bracket for a plus b? Okay, Brenda, I'm not sure if I'm hearing you well. Okay, but I'm just going to repeat this again so that we can have clarity. That's fine if you're lost. It's okay to be lost. Okay, to be lost does not mean you cannot be found. Okay, you have to be lost in order to be found anyways. So aren't we all lost? We all need to be found. So like I said, we take out, so we've all established though that the highest common factor bracket has to be a plus b. Because we take out the common bracket that has the lowest exponent. So that means a plus b. Okay, I'm just going to write to the power 1. That is my highest common factor. Then maybe let's do this. Let's use square brackets so that we can distinguish about what's inside. Okay, so this is the a plus b to the power 1 that I took out. I hope we are good. Okay, so I took out the highest common factor, a plus b. There it is. Can you see that? Let's first establish, are we all together with this a plus b to the power 1 that I took out? Are we happy with that? Because then I'm going to move on to the next step. After taking out the highest common factor, remember it's positive, it's 1, it's a plus b to the power 1 that we've took out, because we take out the common bracket with the lowest exponent. What is left over on the left? Okay, remember we took out 1 a plus b. We took out 1. How many do we need in total? We need 2. So that means there's a remaining a plus b that needs to also be included on the left. All right. Okay. Then here on the left we have x squared. So that x squared obviously is there on the left. We need that x squared, okay, because it is remaining. But since we took out 1 of the a plus b's, but at the end we need 2 of the a plus b's, how many a plus b's do we actually need to write here? We need to write 1 of them. Because remember, in exponents, if the base is the same, we keep the base, we add the exponents so that we can get back those 2. Okay? All right, I hope it makes sense now. Right, so like I said, we take out the common base, which is the bracket a plus b, but the one that has the lowest exponent. So between the square or the to the power 1, we take out the one that has to the power 1, the base bracket that has the lowest exponent. What's left over now on the left? X squared needs to be written, definitely. Then, since we took out 1 of the a plus b's, we need 2 of the a plus b's. How many a plus b's do we need to actually now make sure that we have on the left? We need to have an additional a plus b. Okay? Yeah, because that's how I'm able to get the 2 back when I multiply again. Then, let's go to the right. Okay, I hope we understand now here the side, what makes it possible for us to write this. Okay? Let's go to the right. The positive one that was invisible, we need positive times what gives you a negative. Obviously the signs stay the same. There's no change in the signs inside the bracket if we have a positive taken out. Then positive what? I'm sorry, Geotac. I don't know why your comments aren't published. I see your negative y, but I see it. Okay, it's just that for that previous comment, I don't know, I think TikTok destroyed you there because you said Emma Tunin, and it was, I guess it just wasn't bowing down to Emma Tunin. Okay, now the a plus b that we took out, remember, we have 1 that we took out. We need 1. So do we need to add any more a plus b's? No. So what's left over? It's just negative y. All right. Okay. And that's done. Okay, that's done. Okay. Yeah, so there it is, guys. There it is. And maybe for the distinction of the what's inside the bracket, it's always good to just use square brackets so that you don't get confused with the smaller brackets. Okay? Yeah. It's always, I think, proper to do it that way. Yeah. All right. Yeah. Brenda, I don't know. I think, because I saw your comment there. You said in your school you learned that we only put the power for a plus b, example, x into a plus b, the whole thing squared. Okay. And the thing is, this is a question, Brenda. So I don't understand why you would say, this is a question, it's given to you. You have to answer the question, okay? So in this question, it is given to you that you need to factorize x squared into a plus b, the whole thing squared, minus y into a plus b, and you have to factorize it. So as I said, we need to first identify the number of terms in the expression. So by number of terms, we know that there are 1, there's a minus sign. Yes, maths is very fun. Okay. There's a 1 term, there's a minus sign, there are 2 terms. Then, when we are factorizing, we simply take out the highest common factor, and I've said to you, you identify the highest common factor sign, the highest common factor number, the highest common factor letter. When you do that, please take note. When we take out that highest common factor sign, we always look at the first term of our expression. We take out that sign. Okay, very important. Okay, so when you take out that sign, it's a positive sign. So that's why I say positive sign. Highest common factor number, 1. Highest common factor letter, take out the common bracket. In this case, x squared and y are not common. So we don't take out x squared, we don't take out y. A plus b, on the other hand, is common. Okay, and that a plus b, we take it out, it's a plus b. Okay, it's raised to the power 1 because we take out the common bracket that has the lowest exponent. Okay, so it's very important. So we take out a plus b to the power 1. Then we ask what is left over after taking out the a plus b to the power 1 on the left hand side. What is left over, guys, is x squared. But remember, you took out a plus b to the power 1. So you've taken out one of the a plus b's. You need at the end to have 2. How many a plus b's do you need to then also factor in for your left-hand side? You need to factor in an additional a plus b. All right? Because these are common brackets. It's like you have common bases. So these bases, when they're common, you keep the base. When you are multiplying, you add the exponents. You get back the square. Okay? Right. Then on your right, remember, on your right, you need negative y a plus b. But you've already taken out a plus b to the power 1. Okay. So do you need to add another a plus b? No, you don't. Okay. You just need to take down the negative y because the a plus b will be distributed back to this. Remember, when you expand, you multiply this with that, you multiply that with that. Okay, but you must make sure you take out the highest common factor. I hope we are clear. I hope we are clear. I'm gonna do. Okay, I don't know. I don't know if I'm understanding your question, Deboho. What do you do if you add another plus b? I don't know what you mean. Especially for this question. I'm failing to understand what you mean. Okay, I'm not catching your drift there. Okay, I'm just gonna do this last one and then we'll call it a night for the factorization. Hopefully the person who had asked me to do factorization is now on the clear. Okay. Yeah, yes, it is the last one because like I said, I was just answering someone's question here in the live. Okay, so if you look at this question, guys, this is a question that also requires us to factorize. So what you notice is that the first term is actually this one and the second term is that one because it's separated by a plus sign. So how many terms? There are 2 terms. Then after finding the 2 terms, you use S and L. Yes, so we take out a what? Highest common factor between the sign. The sign here now is negative. Okay, so the highest common factor sign between negative 8 and positive 4 is negative. Very important. Then we look at the number 8 and 4. Okay, because remember the first term dictates the sign that we take out. Okay, so since the first term is negative, we take out a negative. The highest common factor between 8 and 4, yes, is 4. Very good. Between x squared and x, we take the common base that has the lowest exponent. Okay, common base that has the lowest exponent. So that means we have x. Okay, very good. Y and y. Y is common. So we just take y. Because they have the same exponent, we just take out y. Now what's left over? Now people, very important. Since the negative sign is what we took out, it means every sign inside the bracket will change. So we had a negative for our first term. That means that negative will change to positive. Okay? It will change to positive. Okay, does that make sense? So that means negative divided by negative, positive. 8 divided by 4, 2. X squared divided by x. You have 1x, you want 2 of them. How many x's do you need to add? Just 1 more. There's a y, you need a y. Do you need to add any other y? Not even, so we're done. Positive divided by a negative is negative. Or you could say negative times what gives you a positive. That's negative. Okay, so you see the signs change. The minute you take a negative out, the sign for all the terms changes. This is now positive. This is now positive. That way is now negative. Okay, and then negative 4xy times what gives you that? Or you can say 4xy divided by 4xy gives you 1. Done. Okay, done. So I'm gonna give you this for your game challenge, guys. All right. And then we'll pick this up tomorrow morning, my grade 9s. Okay. Factorize these. This is your ACE-Fac homework if you want. Okay. I call this game challenges. We don't call it homework. We call it game challenges. Yes, maths is truly a game. That's why we call these game challenges. So go play the game. Play it enough until you feel like I'm good. Okay. I might give you these. You can factorize these for your yeah, 10 game challenges are always good, guys. Yeah, 10. I'll give you 10. So that was, hey, Kiyotaka, I don't want answers here. Don't give me answers. I just want you guys to do the game challenges. Okay? Yeah, don't give me the answers. I just want you to do the game challenges on your own time. You can do it. But yeah, let's take down first. Kiyotaka is getting so excited. Adjust the camera, please. Okay, sorry, man. I feel like people need more, right? So I'm going to give you 15. I know some of you are bored out of your skulls during the holidays, like you need something to do, right? So it's like I'm your savior, helping you out here to just spend your time doing some maths. Some of you like counting the days till schools reopen. That's another thing. That's what's funny. But when schools reopen, you hate school like nobody's business. Like, what do people ever want actually? It's just funny. Okay, so this symbol is pi, guys. You're gonna finish this in less than 20 minutes. That's good. Okay, if you are a learner like that, that's very good, Kyotak. I really like that. Because the issue as well sometimes with math students is that in as much as we want to obviously do maths and be accurate, what we also want to do is actually make sure that we are able to do problems in the least amount of time. Problem solving does also require us to make sure that we do it within a reasonable amount of time. Lerato has been on my case, my goodness. Lerato, I see your comment. Okay, it's just that priority over this thing, there was obviously this that required a little bit of attention. Okay, and the thing is, I cannot leave something if there's someone that has asked a particular question on something. And I know there was a time commitment about me doing a certain thing at a certain time, but it's just that at that time. Okay, so I'm sorry that I was not forthcoming and honest with that, but it's just that, like I said, something else required attention. So hopefully you can forgive that. But yeah, so yeah, I think the person that actually spearheaded this discussion around factorization or wanted factorization to be done is no longer in the live, but yeah, hopefully it was beneficial to those that joined in and were here. And you guys can do these. I'll see you guys tomorrow, same time, same reaction, if that makes any sense. So yeah, enjoy. Lerato, we wanted to do what? We wanted to do grade 10? And what is it specifically that you wanted done? So these were the other questions. Factorize these ones. And what topic did we want done? Euclidean geometry. Okay, the basics. Yeah, I'm gonna do just the basics, but I'm gonna end this live and restart another one. So these were the first few questions, guys, for those that missed it. The first 7. 3x plus 6, 4x minus 8, 2a plus 12, 5x squared plus 10x squared y minus 5x squared y to the power 8 plus 45x to the power 3 y to the power 10, 7m to the power 3 n to the power 7 minus 14m to the power 4 n to the power 8 plus 63m to the power 5 n to the power 9, and then 7 is m into a minus 2b plus n into a minus 2b. All we are asked to do here is factorize. Okay. Rotsy then, thank you so much, guys. It was amazing. It was Rots. It was amazing. Thank you so much. Thank you. Right. I even saw that there are people here that are just good with these things. 6 to 8. Okay, I'm gonna show the other ones just shortly. So these were the first. Okay, yes, I'm going to go back. Don't worry. Okay, and these were the rest. 8, 9, 10, 11, 12, 13, 14, 15. Okay, right, guys, I hope that was okay. Now I have to really scoot baba. You know what they say, scoot baba. Okay, baba. I have to scoot. I have to scoot out of this life. Grade 9s. Thank you so much. Yeah, it was good. Please go and, like I said, subscribe to the YouTube channel. Go to my bio. There's a link there. It's nicely attached. Check it out. Yeah, we'll see each other again. Cheers, goodbye, bye bye. Let me just end this live and restart. Wait, you're not done. Why don't you screenshot, Kiyotaka? You're not done with what? Are you not done with answering the questions? Screenshot, brother. Screenshot. Again, we don't have the screenshot option. Screenshot, brother. Screenshot. Screenshot, brother. These are the other questions. 1, 2, 3, 4. I know you said you're not done copying. Screenshot, Kalok. Then you have the permanence. Screenshot, brother. Screenshot. Kanye, we don't screenshot. There's no screenshot option in our phone. Screenshot, brother. Let's screenshot. Okay, all right, Debucho, heard you. Andy, like I said, there's a video that I posted on my YouTube channel for the first 2 theorems. Okay, so I'll continue with the grade 11 theorems most likely later on today. All right, it's just that I have to go to school in a few. Okay, I have to go to school in a few because I have lessons, I have learners that I need to attend to physically. Okay, yeah, so I will try, guys. The other thing that's really failing me is my network lately. It's acting up big time. Okay, I'm having real problems with my network. Yesterday I tried to be live, but guys, I was having the worst of time. Okay, so trying. Yes, funny, I'll do grade 9 tomorrow morning because at least tomorrow I won't have school to go to. So 7 a.m. let's bang for 7 a.m. Funny, tomorrow morning 7 a.m. we can continue with factorization. We can go on to the other ones, the other types. All right, yeah, we can take it up from there. If you guys look at the ATP for the year for the grade 9s, if there are other things that maybe we should have done, you should have done in term 1, because remember term 1 and term 2, when you write your June exam, it will be a compilation of both term 1 and term 2 work. So if there are term 1 topics that you feel like you're struggling with, please let me know. I think what I'll do is I'll do a video. Okay, yes, we're going to do the corrections tomorrow. That's the whole point of having the live, so that we can do a follow-up on, yeah. Then the geometry in grade 9, Itumeleng definitely will be doing that. Yasura, funny enough, there's a learner that I actually have that is IEP, that's grade 9 and 10, grade 9. So IEP syllabus, very tough to get a hold of, like the content that they do. I know that largely there's there's things that are similar that IEP does with CAPS. So for instance, I'm really trying to familiarize myself with the ATPs that are done, that they basically use for IEP. But there's obviously a lot of similarity. So I'm currently helping a grade 9 student with IEP mathematics. Yes, definitely a bit more challenging. Okay, great. IEP is challenging, but the learners that are there, man, they understand and they do well. I mean, you look at the IEP results at the end of the year; they're getting a higher pass rate than we, obviously, as public schools are getting. So, yeah. IEP maths definitely more challenging, I think personally more enjoyable. I've seen the papers, and also I think it really promotes a little bit more thinking out of the box for learners. Okay, that's what I like about their approach, and basically exposure as well to certain concepts. So for instance, you'll find that in grade 9 they are getting exposure to things that in CAPS you guys only get exposed in later grades. So that's what's nice about that particular syllabus. So your son's doing grade 9. Yasura, oh, epic. Like I said, I'm helping a grade 9 learner at the moment, privately though, with the IEP. So what I do is that for some people, I charge them, but like I do guest live sessions with a particular person, and I just focus on them. Obviously, the other people can join in and see what's happening, but I give that person priority over asking me questions. I help them specifically, obviously, whilst looking at the comment sections every once in a while, but like they get the chance to really have one-on-one interaction with me whilst I'm doing a live simultaneously. So that's something that I do offer as well. Yeah. So guys, let's end this live for grade 9. Thank you so much again. Yasura, you guys can definitely contact me on the side. Just contact me on the side as well and all of that. So cheers guys, let me love and live you. We'll do corrections. We'll start the live for grade 9s tomorrow at 7. Okay, or maybe even slightly earlier. Okay, because we'll see. Cheers guys.